with a scrap piece of 3/4 inch plywood that I had left over from the router table project. And since we have a router table, let's profile the edges with a beading bit, just because we can. Next, let's cut a piece of 2x2 and screw it in from the bottom so that it's secured in the center and about 1 inch from the edge. We'll also need to drill a couple of pilot holes in the top because this is where we'll be attaching some copper lugs. To make these, we simply take a piece of 1/2 inch copper tubing and use a hacksaw to cut 2 inches from the end. Half of the tube can be placed in the jaws of a bench vise, and when the vise is closed with a significant amount of force, you can see that we're left with a nice flat end. Let's place that on another piece of scrap wood and drill a 5/32 inch hole so that it penetrates through to the other side. I've done this with 4 different pieces, and to clean up the rough metal barbs, I'm using a belt sander to gently file away at the edges until it looks a little more user-friendly. This lug here is going to attach to a 5-foot length of 8-gauge cable. This was left over from when we wound our coils. We'll just need to strip about 2 inches of insulation from the ends to expose the copper wire, then bend the wire over with a pair of pliers to form a little loop. The exposed copper loop can be slid inside the casing, and to make this a permanent connection, let's crimp it onto the cable using the bench vise like we did before. This connection isn't coming apart, and should easily handle the high currents that we'll be exposing it to. The other end of this cable will be our ground clamp. I got this metal clamp for 99 cents, and with the rubber tips removed, it'll conduct electricity. I crimped a piece of copper tube to the end of the wire and secured it to the clamp with the screw. The spring in the clamp is surprisingly powerful. It bites down with a good amount of pressure, and that's what we'll need for making a firm connection with our workpiece. Now, a welding rod could just be pinched to the cable with a pair of pliers, but I went ahead and spent $13 on a proper electrode holder. This makes it look more like a real welder and adds a tremendous amount of convenience and control. Okay, we've got our lugs crimped on the ends of the secondary coils, so let's mount the transformers on the base. You probably noticed that I cut the cable in the middle and crimped them to a common lug in the center. This is because I wanted the option to center tap the transformers to power other devices, like an electrical arc furnace. Look for how to make that in a different project. A few screws can be used to hold the transformers in place, and the grounding clip can be connected by overlapping the respective lugs and pinning them down with a screw. The electrode holder gets attached in the same way, and here you can see there's plenty of separation to prevent the terminals from shorting out. Alright, let's get ready to rig up the electrical system. This cord was saved from one of the microwaves we tore apart, and after exposing the 3 wires inside, I'm going to cut off the green one just to get it out of the way. It's not going to be connected to anything. Now here's the trick to powering the welder. 240 volts AC. I can't recommend this as the safest way to do it, but here's how I did it with a couple of plugs, a connector, and some 10-gauge wire. Each outlet in my house provides around 120 volts AC, and they're connected to a circuit breaker bus bar. There are 2 breaker buses, and if a hot lead is taken from each of the buses, we get 240 volts. Now rather than tapping into the breaker box directly, I ran extension cords to 2 different wall outlets that were 180 degrees out of phase. The extension cords connect to this adapter, which basically just connects the 2 hot leads together. If connected properly, the end result is 240 volts. Looking at the back of the transformers, you can see 4 terminals that connect to the primary coils. I used some salvage cables and wire nuts to connect a hot lead to one transformer and a hot lead to the other. Another wire was used to bridge the 2, connecting them in series. By the way, the color of these wires doesn't mean anything. They're all going to be shock hazards. Okay, to finish up, let's fasten the power cable to the base so it doesn't pull the connections apart if the cable gets jerked around. It's extremely important to remember this system has no on or off switch and can only be used with a power controller like the Scariac. You can see how to build this one in another video. If you remember back to when we inserted our new secondary coils, I mentioned it didn't really matter which way they went in, and here's why. When the power is on and our welding electrodes are connected to a multimeter, we should expect to see around 36 volts, but here we're only getting 2.4. That means the transformers are canceling each other out. To fix this problem, let's just turn off the power and remove the connections to one of the transformers. It shouldn't really matter which one. Then we simply switch the connections around. That's it. This time when we turn on the power and check the voltage, we've got 37 volts. Now rather than leaving all the dangerous components exposed, I think we can build a makeshift casing from this plastic container. Here are the exact measurements if you care to know. I chose to use the lid as a base and use a rotary tool with a cutting wheel to make the surface flat. Our entire welding assembly should fit right in the center without any problems. I gave the whole container a paint job, set the bin into position, and locked it into place. 2 holes went in the front for our electrode cables, and I also cut some ventilation holes on the sides. There's a hole in the back for the power cable, and now our welder is completely finished and ready to test. Let's start by directly shorting out the ground clip with the electrode holder, because this will allow the maximum amount of current to flow. We'll use an amp meter to monitor the primary current, turn on the Scariac, and power up. When the power settles at around 15.5 amps on the primary, you can see it produces about 100 amps on the secondary. The amperage is adjustable, so if we add more power, we can jump the welding cables to over 200 amps. In any case, there's certainly enough power available to strike an arc, sustain it, and weld some metal. You can see some of my first few experiences with the world of welding in another video. Well, that's it for now. If you like this project, perhaps you'll like some of my others. Check them out at thekingofrandom.com.